This is section 5.5, Systems of Inequalities. Now we are going to be solving full systems where we have more than one inequality, and just like when we're doing systems of equations, we're going to be looking for things that solve both, or maybe all of the inequalities we have. But before we can do that, we need to remind ourselves how we solve an inequality that has two variables. So when you have an inequality that has two variables, your answer is going to be a graph. And that's because you will have, most of the time, infinite points that will solve an inequality. But it will be infinite, but not everything, because usually there's something you can plug in that doesn't make it work. So our answer is a graph, because a graph shows us all of the possible answers at once. Okay, so what's the process? So the first thing we're going to do is we are going to pretend that this has an equal sign. So pretend we have y equal to 3x plus 2. And what we want to do this is we want to graph this line, okay? Now, I'm not going to connect my dots yet, but I am going to graph this. So this happens to be in slope-intercept form. And so our y-intercept is going to be positive 2. And our slope is 3, which you can think of as 3 over 1. So we plot our first point, which is a y-intercept is 2. And then we rise 3, run 1. So we can do that. And remember, you can also think of this as negative 3 over negative 1. Numerically, if you do this division, you know that equals 3. This just allows us to reverse our steps. So instead of going it this way, we can go down 3 and left 1 to get more points. You can do that anytime you need to find the slope. Okay, so this line is going to be a boundary between a true side and a false side. And we're interested in the true side. But first I need to finish drawing this boundary line. And the decision I have to make now is whether I connect these points with a solid line or a dotted line. Okay, and how do we decide? We're going to have a solid line if we have greater than or equal to or less than or equal to. And we are going to use a dotted line if we have greater than or less than. Okay, so if we have the equal to, it is a solid line. If we have a without an equal to on it, it's going to be a dotted line. Now, when we were doing inequalities with one variable, in this case we used brackets, and in this case we use parentheses. It's just we have two variables, so we have to do it a little bit differently, but it does mean the same thing. If you have a solid line on your graph, that means every single point on that line is also a solution. And if you have a dotted line, that's the boundary. Everything up to that boundary, but not including the boundary, is a solution. Now in this case, we have just a greater than, so I'm going to connect these points with a dotted line. When you're graphing in MyMathLab, you will use the line tool and graph, and then you'll see a toggle button that will change it from a dotted to solid back and forth. Okay? So this is my boundary line. One side of this is true, one side of this is false. Okay. Now I know all of you have almost certainly done this type of problem before. And when you learned it, you may have been taught you could look at it and just look at the equation or inequality, and whether you had a greater than or less than determined whether you shaded left or shaded right or above or below. A lot of people start second guessing themselves in that step, okay? And not all of the inequalities we're going to graph are going to be linear inequalities. So what I'm going to do is I'm going to show you another method. It takes more paper, but it is always, it's less confusing. You're not, fewer people start second guessing themselves. Now, if you are really comfortable using that method that you may have learned before to graph linear inequalities, I don't care if you use it, but I'm definitely I'm showing you this other method. What we want to do is to choose a test point. And our only requirement here is that it's not on the boundary line. I shouldn't say boundary line, just the boundary, okay? So I can pick any point I want to. And then what we're going to do is we're going to plug in that point into our inequality. And we're going to see if it's true or if it's false, because this is a boundary line between true and false. And just imagine, okay, if I test this point right here and it happens to be true, that means it's on the true side. If I test this point right here and it's false, that means this is the false side and this must be the true side. Now for me, I'm always going to be plugging in a number, and what's the easiest thing to plug in? Zeros. So if my boundary line does not go through 0, 0, that's what I always choose. If my boundary line does go through 0, 0, then I tend to pick 1, 1, you know, something else right in this little area, so because ones are the next easiest thing to plug in. And one of these 4 points will definitely be available to you if your line goes through 0, 0. But anyway, I'm going to test 0, 0. And when I plug it in up here, I get 0 is greater than 3 times 0 plus 2. So that's 0 is greater than 0 plus 2, so 0 is greater than 2, which is false. Okay, so I tested this point right here. It was false, so this whole side must be my false side. Now, anytime you have an inequality, you will be graphing and you will be shading, and we always shade the true side. In my math lab, you will see a little bucket, like a paint bucket, and you'll click that and you'll click on the side that must be shaded. Okay? So basically what this is saying, because this is our true side, at any ordered pair I pick over here, I should be able to plug it in and it would work. So this is a visual representation of every single possible solution to this inequality. And the graph is our answer. This is solving the inequality. Okay, so let's try this one. This one is a non-linear inequality, and it's non-linear, I know, because I have exponents on my x and y. Okay, now you should recognize the equation at x squared plus y squared is equal to 4. We're following the same steps here. You change it to an equal sign, and we're going to graph this boundary. Okay, you should recognize this as a circle. Okay, remember our basic circle formula is x minus h squared plus y minus k squared is equal to r squared, our radius squared. Now compare this to this, and you'll see that your h must be 0 because there's nothing subtracted here. Our k must be 0. And the radius, r squared is 4, so r would be equal to 2. So the center is hk, so the center is the origin, and the radius is 2. Okay, so from our center, we need to go up to, right to, so on, to get the other 4 points. 4 points in each direction. Okay, so I have a 0. Okay, now I'm going to connect these with a circle, and I need to decide whether it's a solid circle or a dotted circle. So right here, I have an equal to, so it's going to be solid. Now I have my template here, and let's get this thing drawn here. So I'm going to draw a solid circle. Okay, now this circle, just like the line up here, is a boundary between a true side and a false side. Now what do we mean by sides this time? We have the inside and we have the outside. Not a right side, left side. We have an inside and an outside. So Again, I'm going to pick a test point as long as it's not on this circle. Okay? Now the center, we plot the center only because it helps us place the circle. This point here is not part of the circle. So I can use 0, 0 as a test point. Okay? So I'm going to use 0, 0 as a test point. So I'm going to take 0, 0 and plug it in here. That's going to be 0 squared plus 0 squared is less than or equal to 4. Well, that 0 plus 0, which is 0, is less than or equal to 4. Now, is that true? Yes, it is. I always want to shade the true side. So since the test point was inside the circle and we got something that is true, we need to shade the inside of this circle. Okay? So everything inside this circle and including the boundary is a solution to this inequality.